Hello, welcome to another stream, Learning Rust. So, last time we programmed a guessing game in Rust. So today we are going to next chapter, which is basic common programming concepts. This chapter covers that concept that appear in almost all programming languages, but like how they are in Rust. So we will learn about variables, basic data types, functions, comments, control flow. So let's get started with it. Okay, first of all, there is variables and mutability. And as we saw in our while we made a game, the variables are immutable by default. That means they can't change value. So we will see about what is it and what are mutable variables here. So for that, let me create a new project, variables, and let's inside it I will quickly open the main file. Yeah, so let our x be 5 and I will here print it like the I will just print it like that. X is like this, and here we will say our x. Okay, now I will try to assign x to 6, and then again I will print it. Now as per the book, this code will not compile, so let's try compiling it again. I will use this to compile it. Cargo run, and yeah, as you can see here, it said that here we assigned x first, and then we are assigning it twice, but it's immutable variable. So what immutable variable is that the variable which won't change its value, which is not mutable. So, and why this is helpful, that if you are designing something in like parallel, so that code can guarantee that this variable won't change. And if there are, you can read about it here, and if some code made an assumption that this never change, and another code is changing it just a little bit only for some times, but that can cause a huge impact. So that's why it is very useful, and it also provides some safety features which you can read about here. And the Rust compiler basically guarantees it. If a variable is immutable, it won't change its value, so you don't have to debug it. And but yeah, as we know, sometimes we have to change the variables, right? That is also very useful. So what we can do is, like, as per the help, let me just do it here. Within our this, we can say it, make it as mutable variable. So what it will do, let me clear terminal, run it again. See, first it was x was 5, and then it was 6. So what mutable variable does, it tells that variable might change its value to the, so our compiler allows it. So there are some trade-offs for using like mutable or immutable. Like mutable can be fast in some places, but immutable can provide some clarity and all that. So yeah, these are some trade-offs for using either of one. You can see it here. Yeah, streaming is fine. Okay, so now, but as you might have guessed already, so what can be, this like immutable variables sound very familiar to the constant in our other languages we use, like C or Python. They are constant keyword. So what's the difference between these variables and constant? Well, first of all, you can't make constant mutable, and they are always immutable. Like we can make variables mutable by adding mute keyword, but we can't do that with constant. And for declaring a constant, we use this const keyword instead of let keyword. And while declaring a constant, as per the example given here, we must always specify its type. We have to always tell its data type. What are data types we will see in just a moment. Yeah, and it can be declared in any scope, and also it can't like be any result of a function or expression which gets computed at runtime. It should be already computed. Constant are also very useful, like if you want like maximum score in a game to be this much, you can declare a constant for that. So in case you want to change it, you can always change it easily. So that's the difference between this variables and constant basically. And last time we also saw that this shadowing. What is shadowing? So if we try to use this code, let me just delete all this. Now I should delete probably better. Yeah, and let me save. Okay, so what we are doing is first declaring an x to be 5, then we are using this let keyword again and again declaring x to be the x plus 1, and we are declaring it to third time. So what happens if you run it? It says x is 12. So what actually happened here is that x gets shadowed here, the next expression. So what it when it is useful, if you want to like convert in types, like first if you want to count the spaces, so we can select spaces this and then we have to calculate its length. So this Rust compiler will automatically change its type if it can, or otherwise you have to supply the specific type which you want if there are possibly many types present. So that's how basically it is done. Like when we use mutable variables, we can't change its type, because you can see in example first it was string, means str not string, and then we are passing it, we are trying to make it an usides, which can't be done with mutable variables, but it can be done with shadowing like we did here. That's what is happening here. First x is 5, then the x gets shadowed. So variable name, we can like we are using the variable name again and again, but with different value. So instead of making here like space string space num, we can use the same variable name for this too. So that's what the use of what we say shadowing. So let's moving on to next thing. Now we are about to see the data types. Like we mentioned last time, there are data types. So what are they? There are two subset of data types. One is scalar and compound. And as you know, Rust is statically typed language, which means like all variables, it should know that the data type of variables at compile time. And the compiler usually can interpret like, so can tell what is the data type of the variable, but when sometimes there are too many possibilities, so that time you have to explicitly tell it's that what data type you want. For example, this is something we used in the guessing game. We first passed it, but after passing there are many types it can be guessed after parsing, right? So that is why we need to specify a type to be used 32 unsigned 32 bit, so it will compiler will know what type we have to parse in. So what are scalar types? The scalar type represents a single value, like Rust has 4 scalar types: integer, floating points, booleans, and character, like other programming languages. Here the integer is number without fractional component, like there is no like 1.0, not like that, it's just a number. So there are, you can see here what are different types of integer in Rust. I means for signed, like when we consider about sign, like number can be negative or positive. So we have to consider the sign, whether it's minus or plus. We we say that signed I and then the bits. So I8 means 8-bit signed integer, I64 means 8-bit 64. And for architecture specific, we can say I sites. And same with unsigned. U means unsigned. So we know that number is going to be only positive. So those are unsigned integers. And yeah, that's basically it. And you can use this type. And so take a look at it there. And how many numbers can be stored? We can calculate from this range, and which is inclusive. Like for I8, you can store minus 2 to power 7 to 2 to power 7 minus 1, which is minus 128 to 127. Like, but and for unsigned 8, we can store from 0 to 255, because we know unsigned bits are only positive. And I size and U size, as we say, it depends on architecture. If you are using 64-bit, then it's going to be 64-bit. If you are using 32-bit, then it will be 32-bit. And they are mainly used for iterating over arrays and all that. We will see about them in just later in this chapter. And there is note that we can also use these suffixes. For hex we can use 0x, for octal we can use 0O, binary 0B, and for byte this. Or we can use like 57U8, which will create a 57 as unsigned 8-bit integer. You can use like this syntax also for creating. And you might have heard about integer overflow. Like here we saw for unsigned 8-bit, we can only represent number from 0 to 255. So what happens after if we try to represent number bigger than 255? Well, if we are compiling in debug mode, like we did here, Rust compiler will make sure that when we execute and there is integer overflow, our program will panic instead of crashing. And we will see about panics in later chapters. But when we compile it using the release flag, so it gets optimized, and instead of panicking, it just wraps it around, like taking a modulo of it. So 256 becomes 0, 257 becomes 1, and so on. So program won't panic, but it will the wrap up value. So if you don't want that, you can, there are many ways to handle these overflows. You can take a look at them later if you want. And then there comes floating types. Floating types, there are F32 and F64, which represent the 32-bit float and 64-bit float. And the modern CPUs have like F64 because it's same speed as F32 but with more precision. So here is like an example. Let x equal to 2.5. So if we don't specify it by specify it, it will get defaulted to 64-bit. And if you want 32-bit floating point number, we have to specify its type to be F32 explicitly too, so that it will interpret it as a 32-bit floating point. And as any other programming language, we can also do this math operation, which are addition, subtraction, product, quotient, and remainder. So which are like division, remainder, all that. And syntax is very same. We can use addition, minus for subtraction, star for multiplication, division, and remainder. And there are many operators. We can use the bitwise and all that, which are covered in appendix B. Then floating types are basically just with some decimal number. So like their decimal points. So 2.0, that becomes a floating point integer. Now what are Boolean types? We know Boolean can either be true or false. and they are just 1 byte in size. So we can, declare it as this, or explicitly tell that this is this variable is going to be boolean, and then assign a value to it. And these are very useful in like if statements and all that, so we will see about them in control flow section more. And the last static type is character type. So character literal is represented by a single quote, not double quote. Double quote is for strings. Character is single quote. So it can be anywhere in Unicode scalar value. It is a Unicode scalar value from this range to this range and this range inclusive. So it can represent much more than just ASCII. It can be Chinese, Japanese, Korean characters, emojis, also zeroed space, like whatever lies between this and this range can be represented like this. You can use emojis, or you can use like ASCII characters, a lot of things. And we will discuss about it in chapter 8 in much more details. Then this is just overview about it. And after this static types, there are compound types that can group multiple values together. So there are basically two primitive compound types, that are tuples and array. So what tuple is basically we can group any kind of values together, but it's fixed length and once declared can't grow or shrink. The value don't have to be of same type, like it can be like in this example here, first is I32, second is F64, and third is U8. So they can be of any type, and this variable to binds this whole tuple, not just anything. If you want to access separate element, we can use any of this either ways. So we can use like we can destructure it by this format, like we can say xyz equal to that tuple, so it will get 500 will get assigned to x, 6.4 get assigned to y, and 1 will get assigned to z. So if we just run it right here, you can say, you will see it here. Yeah, the value of y is 6.4, which was second element. So that's how it works. And if you, an other alternative way is by using dot. So we can index it by like first element will be 0, second element will be 1, third will be 2. So x.0 will be the first element, just like that, because the first index starts with 0. So you can use either of the format, depends on your use case. And then there is array type. So what is array is basically a big chunk of memory where all the values are of same type, and we can declare it like this inside the square bracket separated with comma. And note that this unlike tuple can be of any types, but array has to be of same types of element, like it can contain any different types. No. And here, and there are array is useful when you want to allocate on stack instead of heap, which you will see in the chapter 4. But for now, and array is not flexible as vector. Vector is like arrays, but it can grow or shrink in size. It is allowed to do that. And if you don't know what to use, you can go with vector instead of array. But what are some use cases of array? Like suppose we have this data, like what is say the months of a year, which are not likely to change. Like we know there are only 12 elements and it's not going to change. So we can just use array instead of any other thing. And here the syntax, if you want specify what, like explicitly annotate the array, you can use this syntax. First there will be type, and then there will be number of element. So here let a is the array has I32 elements, which is like 32-bit integers, and there are 5 of them. So, and also if you want like array to be filled with the same element, you can use something like this, the first element and how many times you want it. So like this, our array A will contain 3 for 5 times, so it will result in same like this. That's how the array works. And if you have used any other programming language, you know how to access the element in array. That's basically the same. You can use this index in the square bracket, specify the index, and it will get the element in it. And what's special about the rest is that it it doesn't give any out of bound element. Like if you try to invalid access any element, like let me just try this program here. So if I delete all this and let me just save it and try to run it. So what it is doing is like it asking index and it will return the value at that index. Like at index 2 was 3. So what will happen if I try to access out of this? So I will specify 23. Notice it panicked. Instead of giving like a random value at that address, it actually panics and says index is out of bound. The length of array is 5, but index is 23. And that's how it is supposed to be. It shouldn't do any memory leaking, space giving any index like that. So it doesn't execute this. It will panic on right away here. So it instead of the runtime error, it's no the program, we are getting the runtime error instead of getting any arbitrary random value, which is very good. And this is like one of the safety features in many low level languages. If you used this check isn't done, like you can use any index and it will read some random bytes from that and give you, and this is very bad. So that's it for the today's stream. If you have something, you can always say in chat if there is anything. Not, I will end this. Thank you for watching. See you tomorrow.